back to class, viewers. Yes, it's nice to have you in class. I'm super excited because I have a very good stuff for you guys today. Now we are still looking at the concept of factorization. Without wasting much of our time, on the board we'll be looking at difference of two squares in factorization expressions. Yes, I want us to look at every area that have to do with factorization of algebraic expression. Guys, you will love this. Now we have difference of two squares on the board. Please don't forget, if you are new in this YouTube channel, do consider subscribing to this YouTube channel and turn on the post notification button so that anytime we release mind-blowing content, you will be notified. And don't forget to like this video, make your necessary comment, and share this video to both your friends and your enemies. Now we are good to go. Now follow me as I hold you by the hand and walk you through the process of solving these problems step by step. All right, now let's get started. Now, the difference of two squares is always obtained when you find the differences between two different squares, or when you are subtracting two different squares. So when two different squares were not, you now use the difference of two squares. Yes, you use the difference of two squares when you subtract two different squares from each other, and that's exactly what we have here. So this is x squared minus x squared, y squared. This is x squared minus y squared. So this is equivalent to what? X plus y. You take the first as x plus y, then take the next as x minus y. So in the two brackets, one will be plus, the other will be minus. Are you there? Now let's look at the question that we have here. And this question, I tagged them to be question 46, 47, and 48. Still looking at algebraic simplification. Now, the question number one here, which happens to be 46. So this is solution. Question 46. We have x squared minus 25. Guys, this is very simple. In 1-2 lines, you get your answer, right? Now, what you do here is to see how you can convert this other term to also carry this power of 2. And of course, you know that 25 is a perfect square, which shows that 5 times 5 is 25. So what you need to do is to see what must I do to this to also have a number here that will be raised to the power of 2, and that's your outcome will give us 25. So in this case, all we do is that this is x squared. Now we know that 25 is exactly 5 times 5, and 5 times 5 is exactly the same thing as 5 raised to the power of 2. Therefore, I can simply replace this by 5 raised to the power 2. Now, all I just need to do is to take x plus 5 times x minus 5. Guys, this is the answer. All you just need to do is to see how you can convert both values or both terms to have the power of 2. And the number, the sign between them is negative. Once the sign between them is negative and they all have power of 2, all you just need to do, pick the first term plus the second term, open bracket, pick the first term minus the second term. So the first bracket will be positive, the next bracket will be negative, or anyone can come first. This is it for question number 46. Now let's look at question number 47. Like I said earlier, now don't forget that this is the first term, this is the second term. Alright? So what we are going to do now is to factorize this itself and also simplify this term to also be in power of 2. Now understand that 49 is equal to 7 times 7, right? And 7 times 7 is equal to 7 raised to power 2. Then in place of 49, we are going to have 7 raised to power 2 minus. Now understand that these two terms goes together, so they must be enclosed under the same square. So what must I do to 4? Now understand that this 4 is the same thing as 2 raised to power 2. Why this is y raised to power 2. Now the next thing we are quickly going to do is that this will give us 7 raised to power 2 minus. Now if I have 2 square, y square is the same thing as 2y raised to power or raised to power 2. This is what the fifth law of indices, which says that if I have s y all raised to power a, that this is s raised to power a, y a, right? So if you remember this law in indices, that means we are correct with this. Then all we just need to do is to have this as 2y all raised to the power of 2. Now this is the first square, this is the second square, right? So all I need to do, the first term there is 7, then plus the other term there is 2y. Then open another bracket, 7 minus 2y. So the first will be plus, while the second will be minus. Hope this is clear. Now let's look at the last question before we end up this session here. Now for question number 48, guys, there is no difference between this question and 46 or 47. They are all the same. All you need to do is to see how you can enclose all of these terms here to be under one square, and all of these terms here also to be under one square. So we know that 36 is equal to 6 times 6, and 6 times 6 is 6 raised to power 2, guys. Therefore, this will have given us 6 raised to power 2, x raised to power 2. Then minus, for this other case, this is 25, and 25 is 5 times 5. And 5 times 5 is exactly the same thing as 5 raised to the power of 2. Now, guys, what else do we do? We still have this as 5 raised to power 2, y raised to power 2. Now, when we come back to the fifth law of indices, which says that if I have this all raised to the power of a, is the same thing as s raised to power a and y raised to power a. Therefore, I can convert my expression now from this form to this form, so that I can have only one base to one power and the other base to one power. Therefore, this will give me 6. I will take the base, 6x and base, all raised to power 2, then minus 5y, all raised to the power 2. These are the bases. So now that this is a square, all I need to do is to work with the base. How do I work with the base? I'm going to have 6x minus 5y, close bracket, 6x. Now I have used minus, then plus 5y. This is the answer to this very question. Now, like I explained before, I made it very clear, that plus can come first, minus can come first. Anyone can come first is containing minus, and the other is containing plus. Both cannot be plus plus, and both cannot be minus minus. One will be plus, while the other will be negative. So if this is understood, guys, then we are done with the aspect of factorization using the concept of difference of two squares. And this is only done when you are subtracting two square numbers. Don't forget, when you are subtracting. So if I have multiplication here, that theory will not work. All right, it will not work at all. See you guys in